Welcome back, everyone. Hopefully you feel like you're getting the hang of these by now, but we're going to go through a couple more examples of translated sine and cosine graphs. So here we have, we're asked to sketch the graph of y equals -2 sine of x minus pi on 3 minus 2. The question that it follows on from asks us to just sketch one complete cycle, so that's the domain that we're going to work with. A couple of things to notice straight away. This time the horizontal shift is pi on 3 units to the right, so can make a mental note of that. We've got a shift of 2 units down. The amplitude for this question is 2. The period is 2 pi over 1. Right, so the period is just 2 pi. And the other thing that it's good to be aware of is that this is a reflected sine graph. This is a sine graph that's going to be reflected in the x-axis. So our, I guess, general look is going to be a sine graph starting in the middle but going down first. All right, once we apply all the other transformations as well. So let's get stuck into it. This time the safety net, I guess, has been removed. We haven't been given an initial curve to kind of base things off. But if we think about the graph without the translations, right, without the minus pi on 3 and without the minus 2, then we would just be thinking of y equals -2 sine of x, right? Now, I'm going to do this just in pencil because it's not going to be part of my final graph, but I'm just going to mark in some key points from the graph of y equals -2 sine of x, right? So it's going to start from the origin, and it's going to go down because it's a negative sine graph. Its amplitude is 2, so when it does go down, it's going to go down to -2. It's then going to come back up to its mean position, then going to go up to +2 and come down to here. All right, so if that's one cycle of it, and if you want to, you can, just going to do it really faintly, mark in some dotted lines. The other thing I guess it's important for us to understand is that this, I might do this one in pen, period of the graph was 2 pi, so I'm going to mark that. At 2 pi means this value here is pi, and if we keep just marking a couple more, we've got pi on 2 here, and this will be 3 pi on 2. Right, so that gives us a kind of a starting point, but the graph that we're sketching is going to be this graph moved right by pi on 3 units and down by 2 units. All right, so let's see if we can start to apply those transformations. And the other thing actually I might do just with this original graph, because I know that I'm going to the right, all these points are going to move to the right, the end of this cycle is kind of going to go off the grid here. So I'm just going to actually give myself a couple of extra reference points just working backwards. I've got this one up here, and then just gets cut off, but this would be an x-intercept down here. All right, so a couple more reference points in case I need them. Right, so starting from the origin, if we take this this point here and we move it, well, what are we doing? We're going down by 2 units. All right, and then across to, or to the right, I should say, by pi on 3. Now, the grid's not all that friendly to us here, but if that's pi on 2, we can do this sort of roughly. We can see that pi on 3 is going to be about here. So I'm going to go across to the right by pi on 3, and this will be where my reference point at the origin ends up, down to right by pi on 3. And I'm just going to do this to all of the reference points on the graph. All right, so that was from the origin. Next reference point was this one. Okay, we take this point, we go down to and to the right by pi on 3. Going back to the original graph before the translations, this point here is the next reference point. Take it down to across by pi on 3. And just keep repeating the process. Next one, down by 2, across by pi on 3. Right, now if I just sketch from these reference points so far, I haven't quite got a full cycle. That'll be a maximum. And so to get a full cycle, I might need to go back a little bit and use one of these other reference points. So if I go back to this point here, I can go again down 2 to the right by pi on 3. And if I extend that up, there we go, we've got one full cycle of the graph of y equals -2 sine of x minus pi on 3, take away 2. All right, just for this one, just for now, I'm not going to worry about intercepts just because we're trying to learn the method, but we do know that to get this y-intercept, we can let x equal 0, and to get the x-intercepts, we could either let y equal 0, or we could try to use what we know about how it's being translated to work out the x-intercepts. But we'll leave that one for another video. All right, another one to have a look at, and this one's got a little bit more going on. So firstly, it's a cosine graph, but one of the important things we need to look at is that this equation does not have x with a coefficient of 1. At the moment, the coefficient of x is 2. So the first thing you should do is rewrite your equation like this. So it kind of looks messier because you get 2 sets of brackets, but what this does is it lets you identify that the horizontal translation is pi on 2 units to the right, not pi units to the right. So that's really important. So we now know that we've got a shift of pi on 2 to the right, 1 unit up. Right, the amplitude is 3. Period for this graph is 2 pi over 2. So the period's actually pi. Right, and the shape of the graph, well, it's a positive cos graph. So the shape of the graph, something like that. All right, now, again, like we did last time, we're going to use as our reference the graph of 3 cos of 2x, because that's the graph without any vertical or horizontal translations. And so if we mark in that graph, or at least the reference points from that graph, we know that with a positive cos graph, it sort of starts at the top. So it's going to start at the top, come down to the middle, get to its minimum down here at -3, then come back to its mean position and finish at its maximum. The period of this graph is pi, so we're going to mark this point here as pi on our grid, all right, because that's one cycle, which means this would be pi on 2, this would be pi on 4, this would be 3 pi on 4. All right, and like we did before, we're going to take each of our reference points and this time move them pi on 2 units to the right and 1 unit up. Okay, so this first point here, we go pi on 2 units to the right. So in this case, we're going a fair way to the right. All right, we're going pi on 2 units to the right and 1 unit up. Right, and then we do that to our next reference point as well. So this one down here, we take it pi on 2 units to the right and 1 unit up. Next reference point is this minimum, pi on 2 units to the right, 1 unit up. All right, we get to here. Now you can see I can't go any further to the right here because otherwise I'm off my graph. So what I'm going to do is actually think back to the reference points, these ones that I've just marked in pencil here. And I'm actually just going to make myself a couple of extra ones. This next one here, and the last one, it's just off the grid here, but it would be the minimum down here at negative pi on 2, x equals negative pi on 2. And so from those two reference points, again, we're just using that same pattern, right by pi on 2 units, up by 1. So this one here, we go right by pi on 2, up by 1 to here. This one, right by pi on 2, up by 1. All right, and now with these blue points that I've marked, we do have enough information to sketch our cycle. right? And that would be our graph of y equals 3 cos of 2x minus pi plus 1, sketch for 1 cycle.